Question number 23. A parallel plate capacitor is placed in such a way that its plates are horizontal and the lower plate is dipped into a liquid of dielectric constant K and density rho. Each plate has an area A. The plates are now connected to a battery which supplies a positive charge of magnitude Q to the upper plate. Find the rise in the level of liquid in the space between the plates. Here, this is actual level, and between the plates of dielectric, the level is risen by height h. Now, battery has supplied charge plus Q to this plate and minus Q to this plate. So, on this surface, on surface CD, the induced charge will be minus Q times 1 minus 1 upon K. And on this surface, the charge will be just opposite to it, and already there is minus Q charge. So total charge on this surface will be equal to minus Q plus opposite of this charge. So that is Q times 1 minus 1 upon K. If we simplify, we will get minus Q upon K. Now, we have to consider the forces acting on this surface due to which the liquid rises. So, the different forces are the electrostatic force acting on CD, the weight of the liquid raised, the force due to atmospheric pressure, and force due to the pressure of the liquid below AB. So here, this person. Now, atmospheric pressure term will not be considered because this level and level of points A and B is same. So now we consider when all forces are in equilibrium, then the electric field at CD due to charge, this induced charge, sorry, not due to induced charge, due to charge Q here on this upper plate will be in downward direction, and its value will be given by E1 equal to Q upon 2A epsilon. Now, due to this charge, electric field on this surface will be again in the same direction as due to plus Q charge. So E2 will be equal to Q upon K times 2A epsilon naught. Since these two fields are in the same direction, so net field E will be equal to E1 plus E2. Both will be in downward direction. So we can write it as Q upon 2A epsilon naught plus Q upon K times 2A epsilon naught. So if we take LCM and then we take common, so we will be left with K plus 1 times Q divided by 2A epsilon naught K. Now we consider the force on the charge, induced charge on this. So force will be charge times electric field. So F equal to charge. Charge is minus Q times 1 minus. So here, since force is a vector quantity, so we don't take negative sign. Q times 1 minus 1 upon K times electric field is this much times K plus 1 Q divided by 2A epsilon naught K. Now we simplify it, we take LCM, this will become K minus 1 upon K, and then Q will get squared. So K minus 1 times K plus 1 will become K square minus 1. So this will become Q square times K square minus 1 divided by 2A epsilon naught K. So this k will make it a square, k square. Now, this force will act in upward direction and weight of the liquid raised will act in downward direction. So weight of liquid raised, so that will be mg, and that will be equal to volume into density. So here it will be A into H, area of the plate is A, and height raised by the liquid is H into, so this is volume into density. Density is rho times small g. So this weight must be equal to force upward to make it in equilibrium. So we can write AH rho g equal to q square times k square minus 1 divided by 2a epsilon naught k square. Now our purpose is to get h. So h will be equal to q square times k square minus 1 whole divided by twice of this, a will go in denominator. So twice of a square times k square times epsilon naught times rho g, which is our answer. Thank you for watching.